Scene script. Have you ever wondered just how vast the universe really is? Let's try to wrap our heads around it. Imagine a grain of sand, tiny, almost insignificant. Now, picture a beach filled with countless grains of sand, stretching as far as the eye can see. The universe makes that beach seem like a mere speck. Intriguing, isn't it? Or let's think about it this way. You've decided to take a cross-country trip. You're excited, ready for the adventure. You drive day and night, week after week, and finally, after what feels like an eternity, you reach your destination. Now imagine that journey, but it's not across a country, it's across a single galaxy. And remember, there are billions of galaxies in the universe. Gives you a sense of scale, doesn't it? Now let's delve a bit into the concept of light years. When astronomers talk about the distance in the universe, they don't use miles or kilometers. No, those units of measure are far too small. Instead, they use light years, which is the distance that light travels in a single year. And light is the fastest thing we know. It travels at a speed of nearly 300,000 kilometers per second. So when we say a star is millions of light years away, we're talking about unimaginable distances. The universe, in all its vastness, is filled with countless galaxies, each of them teeming with billions of stars. Each star potentially surrounded by planets, each planet possibly hosting life. It's a mind-boggling expanse that we're still trying to fully understand. It's hard to comprehend the sheer size of the universe, isn't it? But that's just the start of our journey. So, where did this all start? How did the universe come to be? To answer these questions, we turn to the most accepted theory among scientists, the Big Bang Theory. But don't be fooled by the name. It wasn't an explosion as we typically understand it, but rather a sudden expansion of space itself. Picture a balloon being inflated, and you'll get a rough idea. Around 13.8 billion years ago, the entirety of our universe was condensed into an infinitely small, infinitely hot, and infinitely dense point, often referred to as a singularity. The laws of physics as we know them ceased to function under these conditions, creating a bit of a cosmic conundrum. Then, in less than a fraction of a second, this singularity began to expand at an incredible rate. Picture the most rapid inflation imaginable. This is the moment we refer to as the Big Bang. But it's not just that things were closer together back then. It's that the very fabric of space itself was smaller. Now you might be wondering, what evidence do we have to support this theory? One of the most compelling pieces of evidence is the cosmic microwave background radiation. This radiation, discovered in the mid-20th century, is a faint echo of the Big Bang, still detectable today. It's like the universe's baby picture, showing us its state just a few 100,000 years after its birth. Since that monumental bang, the universe has been expanding. The galaxies are not moving through space, but rather space itself is growing, carrying the galaxies along for the ride. Like spots on our inflating balloon, they move farther apart as the universe expands. In the blink of an eye, the universe sprung into existence, and it's been growing ever since. It's a story of cosmic proportions, a story of everything that is, was, and will be. It's the story of our universe. From a hot, dense point to the vast cosmos we see today, how did the universe evolve over time? Let's start with the formation of stars and galaxies, which began as tiny fluctuations in the density of the primordial gas that filled the universe after its birth. Over time, gravity began to pull these denser areas of gas together, creating increasingly larger clumps. As these clumps grew, they started to heat up and glow, leading to the formation of the first stars. The creation of stars marked a significant moment in the universe's evolution. These celestial bodies weren't just points of light in the darkness. They were factories, forging heavier elements like carbon and oxygen in their cores through the process of nuclear fusion. Now imagine these star factories working overtime, producing more and more of these heavier elements. Eventually their fuel runs out, and what comes next is a spectacle of cosmic proportions. Depending on their size, stars either puff up into red giants, shedding their outer layers, or explode in a supernova, scattering their contents across space. This is where gravity steps in again. It pulls these star remnants and freshly made elements together, creating new stars and, for the first time, planets. It's on these planets where the elements formed by stars can combine in just the right way to create life. But the universe doesn't stop there. It continues to evolve, with galaxies colliding and merging under the relentless tug of gravity, forming larger and more complex structures. It's a cosmic dance choreographed by gravity, with stars, galaxies, and clusters following its lead. So the universe we see today, with its vast array of stars, galaxies, and life, is the result of billions of years of evolution, driven by the simple yet powerful force of gravity. From the ashes of dead stars, new stars, planets, and even life can emerge. This is the story of our evolving universe, a testament to the power of gravity and the life cycle of stars. So what's next? What does the future hold for our universe? As we peer into the cosmic crystal ball, several theories emerge about the future of our universe. Each theory, a testament to the wondrous complexity of the cosmos. Let's delve into some of these theories, shall we? One concept that is central to many of these theories is the enigmatic entity known as dark energy. This mysterious force is believed to permeate all of space, pushing galaxies away from each other and causing the universe to expand at an accelerating rate. As dark energy continues its relentless push, the universe could keep expanding faster and faster, stretching galaxies apart until they're isolated in their own vast regions of space. But what happens as the universe continues to expand? Well, we know that stars, those shining beacons of the cosmos, don't last forever. They burn out, collapse, and sometimes explode in spectacular supernovae. As stars age and die, galaxies will lose their luster, dimming until they're nothing more than ghostly shadows against the cosmic backdrop. Eventually, even galaxies could meet their end. Perhaps they'll be ripped apart by the relentless expansion of the universe. Or maybe they'll gradually fizzle out as star formation ceases and existing stars fade away. Either way, it's a sobering thought that these cosmic cities of stars could one day be no more. As for the final fate of the universe, several scenarios are on the table. There's the Big Freeze, where the universe continues to expand until it's a cold, dark, and lonely place. Or there's the Big Crunch, where the universe's expansion slows and reverses, causing everything to collapse back into a singularity. And let's not forget the Big Rip, where the universe's expansion accelerates to such an extent that everything from galaxies to atoms is torn apart. The future of the universe is uncertain, but one thing is clear. It's a fascinating place filled with mysteries waiting to be solved. In this vast, evolving universe, where do we fit in? Our home, Earth, resides in an interesting neighborhood. We're located in the Orion arm of the Milky Way galaxy, about 26,000 light-years from the galactic center. But in the grand expanse of the cosmos, we're relatively in the suburbs, far from the bustling downtown of cosmic activity. Our galaxy, the Milky Way, is just one out of 2 trillion galaxies in the observable universe. Each of these galaxies holds millions, billions, or even trillions of stars, many with their own planets. The numbers are staggering, almost incomprehensible. And yet here we are on this one tiny planet in the vast cosmic ocean. The search for extraterrestrial life is a quest that has captivated us for centuries. As we gaze into the cosmos, we can't help but wonder, are we alone? Technological advances have allowed us to discover over 4,000 exoplanets, planets outside our solar system. Some of these exoplanets lie within the habitable zones of their stars, places where conditions might be just right for life as we know it. Yet despite our best efforts, we have yet to find definitive evidence of life beyond Earth. This doesn't mean we should stop looking, quite the contrary. The universe is vast, and our search has barely scratched the surface. The possibilities are endless, and the search for extraterrestrial life continues to be a testament to our curiosity and our insatiable desire to understand the universe. Understanding and exploring the universe isn't just about finding our cosmic neighbors. It's also about understanding our place in the cosmos. We are, after all, made of stardust, born from the remnants of ancient stars. This connection to the universe is something profound and humbling. In the grand scheme of the universe, we may seem insignificant, but our quest to understand it is a testament to our curiosity and intelligence.